Good evening, everyone. It's a great honor to be giving this presidential address. And you're going to hear later, I believe, from Mwele Malakela, who is the head of the WHO NTD department, about the new roadmap for 2030 that WHO has been working on for the last couple of years. So I thought it'd be interesting this evening to discuss how many NTDs I think we can eliminate by 2030. So just to go back to 2012, when WHO first came up with an NTD roadmap, this was at about the time of the London Declaration, when NTDs were moving up the agenda. And you can see that rather a lot of targets were set for 2020. Global eradication of Yaws and Guinea Worm, elimination of a number of NTDs from some parts of the world, and elimination as a public health problem of several others. So I'm afraid I don't think we're going to achieve any of these targets by the end of this year. But we have made huge progress against NTDs since 2012. Mass drug administration, sometimes called preventive chemotherapy, coverage for populations at risk in endemic areas has increased from 42% to 65%. As a result of this, 500 million fewer people require an intervention against NTDs, and 40 countries, territories, and areas have eliminated at least one NTD. So the overall proposal, and this roadmap has not yet been officially approved by the World Health Assembly. I think that should have happened this month, but World Health Assembly were preoccupied with COVID. WHO have been working on this with much consultation with the NTD community for the last 2 years or more. And the overall goal proposed is that there should be a 90% of reduction in the number of people requiring interventions against NTDs. And nobody should need to pay for this. It is hoped that 100 countries will have eliminated at least one NTD, that 2 NTDs will have been eradicated, and that the disability-adjusted life years lost to NTDs will have been reduced by 75%. How will this be done? Through integrated approaches, multi-sectoral collaboration involving, for example, the water and sanitation community, country ownership rather than vertical programs delivered from outside, and this should be part of universal health coverage, which we are aiming to achieve as a sustainable development goal by 2030. And there should be increased emphasis on measuring the impact of these interventions rather than just counting the number of treatments given. So what are the targets? There are 2 diseases, the same 2, targeted for global eradication. Guinea worm, confirmed absence of the emergence of adult female worms in humans and animals for 3 consecutive years at the global level. And for Yaws, complete interruption of transmission, so not a single new case globally, again for 3 years. There are a number of targets for regional elimination of Trypanosoma gambiense infection, leprosy, and onchocerciasis. And then for those diseases targeted for global elimination as a public health problem, the target for trachoma is that all endemic countries should have been validated as having met the targets. And for lymphatic filariasis and visceral leishmaniasis, only a proportion of countries. So in the next 20 minutes or so, I don't think I have time to discuss all these targets, so I'm going to focus on the 2 targeted for global eradication and on trachoma, because that's targeted for global elimination as a public health problem. So to start with Guinea worm. In the mid-1980s, WHO estimated there were about 3.5 million new cases per year in 20 countries in Asia and Africa. India in 1983 was the first country to officially launch a national guinea worm elimination program. And the Carter Center, thanks to President Jimmy Carter, led the way in launching the global eradication program for guinea worm, and I think Jimmy Carter deserves huge credit for this. Guinea worm is acquired by humans when they drink water from a pond or lake where there are larvae inside copypods, small flea-like creatures that live in the water. So the human drinks the water containing those larvae. So the first intervention is to try and prevent that happening, to provide safe water supplies where that is not possible, to encourage people to filter their drinking water through a cloth before they drink it. The life cycle continues when an adult worm develops in the person who drank that water. They then have an adult female worm emerging from usually the skin of their foot or leg. When they put that foot in the water, the larvae come out and go and look for another copypod host. So the goal here is to identify people with guinea worm and try and prevent them putting their foot in that water. And then finally, it is possible to treat the water with an insecticide, a bait, sometimes, well, scientific name is Temifos, to try and kill those hosts, those copypods. In terms of surveillance, it's not difficult to diagnose guinea worm. There are not many, well, there are no other diseases that make a worm come out of your leg. So this can be done by village volunteers. They, in addition to trying to contain the case, prevent that person putting their foot in the water, they report the cases to their supervisors, and this goes back so that reports come in and we know exactly where people are acquiring guinea worm to focus our interventions. Huge progress has been made since the mid-1980s when they were estimated to be 3.5 million cases a year. By 2006, it was down to about 25,000, and by 2014, down to 126. So an amazing achievement. Unfortunately, in 2014, this paper was published, The Peculiar Epidemiology of Dracunculiasis in Chad, drawing attention to the fact that in Chad, where surveillance had been weak for a few years, there were suddenly a lot of new cases in places where they had not been seen before in humans, but in which there were many infected dogs. There had been previous case reports of guinea worm in dogs, but only isolated cases, and this was the first time people realized that dogs were an important reservoir for human infection, and these worms are identical to the worms found in humans. Guinea worm has been found subsequently not only in dogs, but in cats and baboons in Chad, Mali, Ethiopia, and South Sudan. So clearly, this poses a challenge for the global eradication program. And this is data from Chad showing the number of cases in humans and dogs over that period, 2012 to 2017. And you can see here that every year there are hundreds of cases in dogs in blue and a mere handful in humans. So getting rid of those infections in dogs is going to be a challenge. How do dogs get guinea worm? Humans get it by drinking water, but dogs lap the water. So it's thought through lapping water, you will not ingest those copypods containing larvae. So it seems that they get infected by eating infected frogs or entrails of fish which contain the larvae. So frogs and fish can be so-called paratenic hosts in whom the worm will not develop further, but if a dog eats them, then it can develop in the dog. So how can we prevent infection in dogs? Well, health education, encouraging people not to leave the fish entrails lying around for the dogs to eat, increasing the use of a bait on infected water sources, giving rewards, $20 for each dog with guinea worm that's tethered, and further research, trying to understand what are these paratenic hosts that are passing it on to the dogs. So where are we now? In 2018, there were 28 cases, 17 of them in Chad, 10 in South Sudan, which was upsetting because there had been no cases the previous year in South Sudan, and 1 in Angola, which was also quite a big concern because guinea worm had never been reported from Angola before. Last year, 54 human cases, again, most of them in Chad, 1 in Angola, 4 in South Sudan, and 1 in Cameroon. And I'm sorry to say that in 2020, we've just heard they have identified 7 cases in Ethiopia, which had not had a case for the last 4 years, I think, in the Gambela region, which borders South Sudan, and in which there are known to be many infected animals. So will guinea worm be eradicated by 2030? I think it's really remarkable how much progress has been made in the past 30 years, from 3.5 million cases a year down to less than 100. It has been eliminated from 16 countries, but a number of challenges remain. We don't know the impact of COVID-19, of the pandemic, on guinea worm programs. We know it's difficult to work in conflict zones such as South Sudan. And are we going to be able to deal with those animal reservoirs? Because remember, the target is no cases in humans or animals by 2030. And finally, now we're down to so few cases. Will the funding continue? And finally, and extraordinarily, there is now a guinea worm, Save the Guinea Worm Foundation. And I don't know if you can read this. I'm not sure I can read it myself. It says here, a cartel of powerful organizations is conspiring to exterminate the living endangered species from the planet. Let's hope they succeed. Moving on now to Yaws, the second NTD targeted for elimination initially by 2020, then by 2030. Yaws is an endemic non-venereal treponematosis. It is caused by Treponema pallidum, the same bacterium which causes syphilis. It is spread from skin to skin, mainly between children in warm, humid environments, and it causes skin lesions, which can be disfiguring, as you see here, and lesions of the bone, which can be painful. This was the first eradication program launched by WHO soon after WHO was founded in 1952. How was this to be achieved? Active case finding, treating cases with long-acting intramuscular benzathine penicillin. In communities where the prevalence was more than 10%, everyone should be treated. Where it was between 5 and 10%, all children, all active cases and their contacts should be treated. When it was less than 5%, active cases and their contacts should be treated. Surveillance was through clinical examination, but there are other infections that can cause very similar skin lesions. And moreover, latent infection is common, which can relapse. So we also needed serology. This was really an extraordinarily successful program. Almost 500 million people were examined in some of the most remote communities in rainforest areas in Africa, Asia, and South America, and more than 50 million people were treated. The global prevalence was reduced by more than 95%. But of course, once people stopped seeing cases, surveillance was discontinued, and unfortunately, Yaws came back. What happened next? Well, this is a picture of Oriol Mitja, a young doctor from Barcelona, who came in our DTMH course at the London School, I think, in 2010. He then got a job in a gold mine, working for a gold mining company in Papua New Guinea, and persuaded them to fund a randomized controlled trial for the treatment of Yaws, comparing a single oral dose of azithromycin with the standard treatment of intramuscular benzathine penicillin. He showed that the two treatments were equivalent. So here was a single dose oral treatment that was effective against Yaws. That paper was published in 2012, and in 2013, WHO, to their great credit, convened a meeting in this rather nice village on the shores of Lake Geneva and came up with a new strategy for global eradication of Yaws by 2020. There was to be an initial round of community-based mass treatment. This is quite a high dose of azithromycin, 30 milligrams per kilogram to the whole community. Subsequent surveys every 3 to 6 months, treatment of active cases and their contacts. And once no more cases were found, clinical cases, there would be a switch to surveillance with serological surveys in young children to ensure that transmission has been interrupted. Serology is much easier than it was in the 1950s. We now have simple point-of-care tests for treponemal infections. All you need is 1 drop of blood from a finger prick, and you can do this test anywhere. You don't need a lab, you don't need to keep them in a fridge. There were still some unanswered questions at that time. So mass treatment with azithromycin has been used for trachoma elimination for more than 20 years now, but at a lower dose, 20 milligrams per kilogram to a maximum of 1 gram. Would that lower dose work for Yaws? How many rounds of mass drug administration are needed? And what exactly do you mean by contact? Well, the answer to the first question was positive. We compared the lower dose, 20 milligrams per kilogram, with the 30 milligrams per kilogram dose in Ghana and Papua New Guinea, and showed that they were equivalent. So mass drug administration for trachoma should have an impact on Yaws in places where those NTDs overlap. Not that there are that many of those, unfortunately. We know that Yaws transmission continues. There are a number of countries still reporting cases, but there are a lot of countries that aren't reporting cases anymore that used to report them, so we don't exactly know the burden of disease or where it is. We have access to azithromycin donation, not from Pfizer, who donated for trachoma from another company, but there are a number of challenges remaining. So these are the countries in orange that were formerly endemic for Yaws that have not reported cases now for a number of years. Is this because there are no cases or because they've stopped reporting them? We don't know. India and Ecuador have eliminated Yaws, so there has been some progress. More bad news is that Oriol Mitja, again in Papua New Guinea, followed up those communities that had received a single round of mass treatment, found that the disease re-emerged, and found that in a few cases of re-emergent disease, a mutation had occurred in Treponema pallidum, which confers resistance to macrolides. So these were azithromycin-resistant strains, as have also been found in syphilis. So this was another concern. And finally, animal reservoirs. We know that Treponema pallidum, indistinguishable from strains that cause yaws, are found in non-human primates in a number of African countries, as you see here. Whether transmission occurs from these non-human primates to humans, we don't know, but it is, again, a concern that there appears to be an animal reservoir in many yaws endemic regions. So I think there are a number of challenges ahead to achieve yaws eradication by 2030. Firstly, we don't really know where the cases are. Secondly, funding for the eradication program. We know the clinical signs are not very specific. There are other infections, for example, Haemophilus ducreyi, better known as the cause of chancroid, can cause very similar lesions in children. Azithromycin resistance, I've mentioned animal reservoir, and of course the unknown impact of the COVID-19 pandemic. So moving on now to trachoma. The target here is elimination as a public health problem. What exactly do we mean by that? So the picture on the left here shows a child with active trachoma, TF. This is follicular trachoma. Each of these little white spots is a trachomatous follicle. You see more than 5 of those in the central region of the everted upper eyelid. That child has TF, has active trachoma. Repeated infections over many years lead to scarring of the conjunctiva, and as those scars contract, the eyelashes turn inwards and scratch against the cornea. This is, as you may imagine, extremely painful and eventually leads to blindness due to damage to the cornea. So the target here is that there should be a TF prevalence of less than 5% in children aged 1 to 9 years in every district in the world, and a prevalence of trachomatous trichiasis, the lashes scraping the cornea, of less than 1 in 1,000 in every district in the world. How is this to be achieved? Through the so-called SAFE strategy: surgery to correct those interned lashes, antibiotics, mass treatment with azithromycin given annually for at least 3 years, and face washing and environmental improvement to reduce transmission. How are we getting on? The Global Trachoma Mapping Project was the largest disease mapping project ever undertaken and was completed in 2016. More than 2.5 million people were examined in more than 1,500 districts in 29 countries. So we know exactly where we need to focus our efforts for trachoma elimination. 9 countries have already been validated by WHO as having met those targets, and 4 additional countries are awaiting validation. The number of people receiving azithromycin mass treatment is now almost up to 100 million every year. And as a result of that, the number of people needing antibiotics has been reduced between 2013 and 2018 from over 230 million to 158 million in 2018. More than 200,000 people are operated on every year for trachomatous trichiasis. And as a result of that, people needing surgery for trichiasis, the number has fallen from more than 8 million in 2007 to just under 3 million in 2016. You can see here there are still some regions, sometimes conflict, areas where there is conflict, such as South Sudan. Also in Ethiopia, there are some districts which still have a high prevalence, but there are not so many of them. And looking at what's happened in the last 10 years, and predicting what is likely to happen on the basis of what we know, WHO has come up with some forecasts based on the most recent data we have on TF prevalence, the number of years of mass treatment already completed, and making some assumptions that districts that have not yet received treatment will start immediately, that donation of azithromycin and funding will not be a problem, and we know that Pfizer have agreed to continue the donation for as long as it's needed. And finally, no disruptions to programming due to insecurity or other factors. And here, clearly, we're a bit concerned about COVID-19. So this is a prediction based on those assumptions that well before 2030, we will have met the target of global elimination of trachoma as a public health problem. And this would be a fantastic achievement, and I very much hope we can achieve it. So just to go back to the proposed overall goal of the NTD 2030 roadmap to end the epidemic of NTDs, we hope to see a 90% reduction in the number of people requiring interventions against NTDs. 100% of those endemic populations should not have to pay for those interventions out of pocket. 100 countries will have eliminated at least one NTD. 2 NTDs, Guinea Worm and Yaws, will have been eradicated, and the number of disability-adjusted life years lost to NTDs will have been reduced to 75%. These are ambitious targets. I have to confess I'm a little skeptical about Yaws eradication by 2030. I do think that is a very ambitious target, but let's hope we can meet most of these objectives by 2030. And I look forward to hearing from Wele Malakela, who is doing a fantastic job as director of the WHO NTD program, and to working with her to try and achieve those goals in the next 10 years. Thank you very much for listening, and I'm sorry I can't see you all.